In these problems, we're trying to identify some graphs of the square root function. And before we jump into these, let's take a look at what the mother function, as they say, is. So let's just look at y equals the square root of x and what that looks like. A couple of things about this. You should know you can't put a negative number under this radical sign. We're not dealing with imaginary numbers on this graph. This is just plain old real numbers. So there will never be anything over here on this side of the graph. Because the square root of something that's positive is always positive, there'll never be anything down here either. So the graph is all going to be in the first quadrant. Now, I think if you're not sure the way a graph looks, the best thing to do is just make a chart and plug in some numbers. This is pretty easy. We could plug in 0 for x, we'd get 0 for y. If you plug in 1 for x, you get 1 for y. If you plug in 4 for x, you'd get 2 for y, because 2 is the square root of 4. So what you end up with is something that is a curve that gets, it rises all its length, but it gets less and less of a rise as it goes on. So that is what y equals the square root of x looks like. Let's take a look at our problems now. Here we have y equals the square root of 6 times x. So this is going to look very similar to that same shape. X can't be negative, y can't be negative. It might just be squished a little bit. So let's take a look and see if we can figure out which one of these graphs it is. It's definitely not going to be C because I just said y can't be negative. It's not going to be B because x can't be negative here. So is it A or is it D? Now D has the curvature of our mother function and A has a curvature that's reversed from that. How am I going to know which one it is? You can always plug in some points. Again, 0, 0 is going to be, whoops, x and y. 0, 0 is going to be on this graph, and it looks like it is for both of them. Let's pick some other point. We have 6 times x. What if you plugged in 6 for x? Then you get 36. That's easy to take the square root of. So 6 and 6. 0.66 should be on this graph. Let's look at this graph. We've got 1, 2, 3, 4, 5, 6, 2, 4. So it looks like it's there. And how about this one? 1, 2, 3, 4, 5, 6. That looks like it's there as well. So that didn't help us much. Let's try to find some point maybe to the right of this over here. What happens when x is very small? Let's say, ooh, I've got a good idea. Let's say x equals 1/6. When x equals 1/6, you have 6 times 1/6. You'd get 1. The square root of that is 1. So the 1 should happen really close to the y-axis where x is 1/6. Here, the 1 doesn't happen until we get somewhere past 1. So it looks like here we have 1/6 and 1, and D must be our function. So it preserved the shape of that curve of the original function. Let's look at another one, which is the graph of the equation. And here we have y equals the negative square root of 5x. Aha. So once again, just looking at this, I know I can't put a negative value in for x. So x is never going to be negative, and we can get rid of this guy right away. In fact, x is always going to be positive, and what this square root sign evaluates to is always going to be positive. And then we're putting a negative sign on it. What that means is y is always going to be negative. So here y is positive, here y is positive. Here, x is positive and y is negative. By process of elimination, it's got to be B. If you want to make doubly sure, you could put in a few points here. The point 1/5 negative 1 should be on here. That looks like that happens right in there. You could test a few other points if you want to, but that's going to be our graph for this one. Let's try one more. Now this one is a little bit strange because they have swapped the place of x and y. So the question is, what does that do to our graph? They've also multiplied it by 2, added 3. And I think in this case, if you're bewildered what might be going on, let's do a little logic first, but then let's make a table of x and y values and see if we can match it up. First of all, we should know, since we've got y under the square root symbol, that y can never be negative. So look here. Here we have y values that are negative. We're going to lose that one. Here we have y values that are negative. So already we've got it narrowed down to B and D. And if y is never negative, let's say y was 0, then x would be 3. So we've got the point 3, 0 on here. In fact, it looks like x can never be negative as well, so b's not going to fit. Let's just make sure that our point 3, 0 is on here. 1, 2, 3. Yep, there it is. And you could plug in a few more points if you want to, but I think we've got this one figured out. So that's a little bit of work with graphs of the square root function. My name is Larry. I'm a teacher at EdVisions Off Campus, an online project-based school in Minnesota. If you're interested, you can check us out on the web at lovethischool.org. Thanks.